Okay, let's look at two examples to calculate how we can just get to the force, the resultant force, and the location. Example one is talking about a gate, a rectangular gate, has got a like 2 meters wide, like this one, and 3 meters high, like this one. This is the gate, is a parallel to the screen. So you can, it's a standing here, and we're just gonna need to calculate the force, the resultant force and its location. So the gate is hanging around its top vertically. So for example, hanging around this like the H, top H, which is 1 meter below the water surface. So the question is to calculate the pressure at the bottom of the gate. Okay, so we need to just calculate the pressure at the bottom of the gate in here. And section B, we need to calculate the resultant hydrostatic force on the gate. Okay, the resultant force. And C, we need to determine the depth at which the resultant force acts. So how are we just going to go with this example? So first of all, for section 1, we need to just use the formula that we have, a very simple formula to just calculate the pressure, which is the rho GH, and the rho is like the rho of the water, 1,000. If it's not given, you can just assume all the time 1,000 for the density of the water, times the gravity acceleration 9.81, times the h, which is like a 3 meters plus 1, 4 meters from that point to the water surface, which is like the 4 meters. 3 meters is the height of the gate, plus 1 meters, which is 1 meter below the water surface. So times 4, so the resultant is 39.24 times 10 to the 3 newtons per square meter, or 39.24 kilonewton per square meter, or kilopascals. So this is like the result for section A, as simple as this. Let's look at section 2. If we want to just look at the section 2, the force, we can just calculate the pressure at the centroid, okay, rho GHG of the centroid of the area times the area of the surface. So rho GHG times A. What is the centroid? The centroid of this rectangular is the intersection of the diagonals. So the intersection of the diagonals and its depth to the water level is very simple, pretty simple to calculate. It's like a 1 meter plus half of the depth is like the 3 second. So which is what, like 1.5 plus 1 is 2.5 is hg. That's it. The area of the gate is like a 2 meters times 3 is like a 6 square meter. And eventually the force, you need to substitute all the parameters, all the values for in this kind of like formula here, which is like 1,000 for the density of the water, 9.81 gravity accelerations, and hg is like a 2.5, 1.5 here, 1 meters here, like a 2.5 we calculated here, hg, the vertical depth of the center to water surface, times area, which is 6 square meter. And the resultant is 147.15 times the 10 to the 3 newtons. Just bear in mind, the units of the force is newtons, but the units of the pressure is Newton per square meter or Pascal. Please don't get confused these two like the parameters that if you're just going to use them by mistake, it's just going to be like the wrong. So you're just going to, if you're just going to use like the newtons for the pressure or Newton per square meter for the force, this is like the not the correct units. Force all the times newtons, and pressure Newton per square meter or Pascal. Okay, let's look at section C, the last section in this example. For this example, we need to determine at which the resultant force acts. Okay, for this one, we need to calculate the center of the pressure. As you know, we have a simple formula to calculate this, to calculate the vertical depth of the centroid, HP, which is equal to the IG, a second moment of the area, divided by A, the area of the gate, times HG, which is the vertical depth of the centroid. Outside the bracket, plus hg, which is again the centroid. So it's like, as you can see here, the vertical depth of the pressure is larger than hg, as big as this one. This kind of like the terms inside the bracket. So you can see you need to just calculate all the terms here. Ig, which is the second moment of the area, we saw this one before, that the second moment of the area, if it's like going to be turning around like the its depth vertically, it has to be, the second moment of the area is calculated L times D cubed over 12. So the L in this case, L is the like the width, D is the height that it is turning. So 3 cubed, which is 8, divided by 12. So it's just going to be like a 4.5 meters to the fourth. Or just bear in mind the unit is like a meter to the fourth. So AG and HG can be calculated and substituted in this formula here, and we can put it here. 4.5 substitute for AI divided by 6, which is A, times 2.5, which is the centroid we calculated before, plus 2.5. So you can see here 2.8 meters is the HB, is a 30 centimeters further down than the centroid 2.5. So we can see like the 30 centimeters lower than this, further down to get to the like the P. So that's the like the location of the P. So this is the example 1. In the next example, we're just going to look at a little bit more complex problem.